Okay, so next what we are going to do is called as quantifiers. Now I'll give you a statement. The statement is say x plus 3 is 5. Okay, so we have x plus 3 as 5. Now in this, if I ask you whether this is a statement or not, so x plus 3 is 5, you will say when x is 2, this becomes a true statement. But when x is anything other than 2, like say x is 0, 0 plus 3 is 3, 3 is not equal to 5, we get the statement as a false statement. So if you say x is 2, it is true. If you say x is anything else, it is false statement. But we can't say this has a certain truth value. We can't say that, right? So this is a statement, open statement, it does not have a fixed truth value. Okay. But in that case, then if I use quantifier, now there are two types of quantifiers. One is universal quantifier. Okay, one is universal quantifier, the other is existential quantifier. So we have two types of quantifiers: universal quantifier, existential quantifier. Now in universal quantifier, I write down say for all x belonging to the set of natural numbers, x plus 3 is 5. All natural numbers. For all natural numbers, x plus 3 is 5. So if I give 1, 1 plus 3 is 4, not equal to 5, it is false. Only for one natural number, that is 2. 2 plus 3 is 5. If you take 3, 3 plus 3 is 6, not equal to 5. If you take 4, 4 plus 3 is 7, not equal to 5. So, not for all natural numbers, x plus 3 is 5. So, this becomes a false statement and has truth value f now. So, earlier, it was an open statement. Now, after putting this quantifier, for all x belonging to the set of natural numbers, x plus 3 is 5. If this satisfies or is satisfied by all natural numbers, then only it becomes true. That is called as universal quantifier. So it has to be true for all natural numbers. Is it true for all natural numbers? No. You have to say false statement. Okay. Now in this, if I use existential quantifier, there exists x belonging to the set of natural numbers such that x plus 3 is 5. So when I say there exists, when I use this quantifier, there exists natural numbers such that x plus 3 is 5. So if I take this as a quantifier, existential quantifier, then this has to be true for at least one natural number. So for at least one natural number, x plus 3 is 5. For at least one natural number, x plus 3 is 5. And yes, it is true. Right? There exists a natural number 2, for which 2 plus 3 you are going to get as 5, for which LHS is going to be equal to RHS. In this case, there is one value of x which satisfies the equation, and therefore we say the statement is a true statement. So it got its truth value. The open statement got its truth value. Either you put existential quantifier or you put universal quantifier. If you're putting universal quantifier, it has to be true for all the natural numbers. If you're putting existential quantifier, it has to be true for only one natural number. It can be true for more, but it has to be true for at least one natural number. And yes, the natural number here for which this statement becomes true is 2. Okay, so this is how the quantifiers work. Okay, we can take some other example to understand the quantifiers better. Okay, universal, existential. Okay, so it's got this truth value. It is not true for all natural numbers, false. This is true for at least one natural number, 2. and then you have to say true. There exists a natural number 2. Okay. Example, let us take A, which is x such that x is a prime number and x is less than 10. So there is the set A, which is the set of prime number less than 10. So what is A? You can say A is 2, 3, 5 and 7. Yes, these are the 4 prime numbers which are less than 10. So we have 2, 3, 5, 7. Okay, now in this, I can give you a few statements. Okay, the first statement is, for all x belonging to A, x plus 3 is less than 10. Next is, there exists x belonging to A, x plus 3 is less than 5. For all x belonging to A, x square is greater than 0. There exists x belonging to A, x plus 7 is equal to 10. For all x belonging to A, x plus 2 is less than 10. Okay? Yes. So if I try this, the first statement, I have to write down the truth values of the statements written over here. So we have 5 statements. I'm going to write down the truth value. Okay, so first statement says, for all x belonging to A, x plus 3 is less than 10. In that case, I would say x is less than 7. Is it true? Is it true for all elements of A that they are less than 7, 2 less than 7, 3 less than 7, 5 less than 7? For 3 elements it is true, but 7 less than 7 is false, and therefore we say this is a false statement. See, when I use universal quantifier, it has to be true for all the elements of A. It can't be true for 3 and 4th element can't be left out. Okay, so therefore this is a false statement. Now next statement, if you pay attention to, they have used existential quantifier, and the example is, there exists a number. When I say there exists, it means I'm talking about at least one number belonging to set A. So there exists number belonging to set A such that x plus 3 is less than 5. So when I say x plus 3 is less than 5, we analyze this as x less than 2. Do we have a natural number less than 2? एक भी रहेगा तो भी चलेगा. Even if we have one natural number less than 2, चलेगा. But नहीं, we don't have it. So we say again the statement is a false statement. Even if we have one natural number less than 2, it would have done. It would have been true statement. For all numbers, natural prime numbers, x square is greater than 0. Yes, it is true. So it is true for all natural numbers. The square has to be positive. So you square each, you get positive. There exists a number from A which will satisfy this equation. Do we have that? Yes, we have 3 which will satisfy the equation. But 2 won't satisfy, 5 won't satisfy. But we want, when I use existential quantifier, we want at least one element to satisfy. And the at least one element which we want here to satisfy this is 3. So it's done. So from this I can say the statement is a true statement. When I say existential quantifier, there has to exist at least one element satisfying this equation. So there exists a number where x plus 7 is 10. Yes, there exists a number 3. For all numbers x plus 2 is less than 10. For all numbers x is less than 8. For all numbers of A, we say the numbers are less than 8. Yes. All of them satisfy this. Okay. So I repeat, when you use for all, the property has to be satisfied, the equation has to be satisfied, equation or inequation, whatever it is, it has to be satisfied by all of them. Okay. So 2 satisfies, 3 satisfies, 5 satisfies, 7 does not, false. Even if 1 will satisfy, it will be considered as true, but no one satisfies, false. All will satisfy, true. Yes, only 3 will satisfy, but at least 1 should satisfy. 3 will satisfy, true. All will satisfy, true. So this is how the quantifiers work. The for all is universal. Universally, for all the elements of that set, the equation or inequation has to be true. Then only the statement will be considered as true. Otherwise, it will be considered as false. And in existential quantifier, even if you get one element, at least one element should satisfy the equation. So even if you get one element satisfy the equation or the statement can be considered as a true statement, as in this case. Here no one is satisfying, and that's the problem. That's why we are taking the statement as a false statement. Okay, so this is how the quantifiers work. It's very simple. Existential quantifier, there exists only one element should satisfy. More will satisfy, chalega, but minimum one element should satisfy. And universal quantifier, all should satisfy. Okay.